Hello everybody and welcome to the second video on linear algebra in our course about machine learning. So in the previous video we saw some notations about what's a matrix, what's a vector, and we learned some to do some operations on these matrices and vectors. And in this video we are going to do just about the same. So the first question that might pop up in your head is how to do combination of operations. We do that simply in scalar world, but how to do it in matrices and vectors world. So, for example, we have this equation, and we want to calculate the result. I used here vectors intentionally just to show you that dealing with vectors is the same as dealing with matrices in this case. So yeah. So how to do that? First, it's the same as scalar problems. So we start with multiplication and division, and then we go to subtraction and addition. So we start with this part and multiply, do the scalar multiplication, the usual one we learned last video. And yeah, 2 by 5, 10, 4, 0, and 1, and 2. Sorry. And so the result is that. And then we do this part, and so we divide 2 by 3, 1 by 3, 0 by 3, and 3 by 3. And the result is that. Okay? So, and then since the two vectors have the same shape, so we can add them together, and the final result is that. Easy and simple, right? So, how to do now things get a little bit harder. How to do vector matrix multiplication or matrix vector multiplication? It's a little bit harder, right? So let's suppose we have aij is in the set of real numbers with the shape n multiplied by m or nxm, and the vector y in the set of real numbers. You might ask, how did I know that this is a matrix and this is a vector? Two things. First, ij here just one index, so of course it's a vector. The second thing, in math usually we note the matrices with the capital letters and the vectors with small letters, just as a like a notation fact. So yeah, we have a condition. The second dimension of A must be equal to the dimension of Y. The second dimension of A, which is here, M, must be equal to the dimension of Y. Now, if this condition is fulfilled, we can do the multiplication. A by Y. So for example, we have this matrix. It's a matrix of 3 by 4, and we want to multiply it by this vector, which is 1, 2, 3, 4, four-dimensional. So the second dimension, that means the columns, 1, 2, 3, 4. Okay, the columns are 4, the dimension of the vector is 4, so we can do the multiplication safely. 3 by 4, 4 by 1, which is, as we said before, a special case of a matrix. You can note here they are the same. Now that equals that. But how did we do that? You like you have the result, but how did we do that? Let's let's see. So you see this row, we come to the first row. We multiply element wise. What do I mean element wise? The first one multiplied by the first one plus the second one multiplied by the second one plus the third one multiplied by the third one plus the fourth one multiplied by the fourth one. Let's do some calculation. 2 multiplied by 2, that's 4. 0 multiplied by 1, that's 0. 3 multiplied by 0, that's 0. And 1 multiplied by 3, that's 3. So we had 4 and we have 3, and the others are zeros. 3 plus 4 equals 7. Let's go to the second row then. 2 by 2, that's 4. Then 5 by 1, that's 5. And 8 by 0 and 0 by 3, that's 0 and 0. So we have 5 and 4. 5 plus 4 equals 9. Here it is. Then 1 multiplied by 2, that's 2. And 1 by 1, 1. 0 by 0, 0. And 4 by 3, that's 12. So 12 plus 1 plus 2. 12 plus 1 equals 13, plus 2, 15. And that's 15. And that's how we did matrix vector multiplication. I hope you understood that. If you didn't, just pause it or try again to watch the explanation. And I hope you understand it. Just go row by row and element-wise multiply the elements element-wise. That means the first with the first, the second with the second, the third with the third, and the fourth with the fourth. And then add all the results together and put them in the first as a first element of the produced vector. And one other note. This is very important note. It will save you a lot of time. It will help you in the future. The produced vector dimension is 3 by 1. You can notice that this 3 actually came from here. And this one came from here. So the produced vector takes as a first dimension the dimension of the matrix, and as a second dimension the second dimension of the vector. So basically you can remove this and remove this. You take 3 multiplied by 1 equals 3 by 1. Actually you can know that even before, like you just see that, and even before knowing the results you can know the dimension of your vector directly. Next, so now how to do matrix to matrix multiplication. That looks like kind of trickier, right? For example, we have this matrix. We want to multiply it by this matrix. First, we check our condition. Is the second dimension of the first matrix equal to the first dimension of the second matrix? 3 by 3 and 3 by 2. 3 equals 3, so we are good to go. Now, I want you to predict what's the dimension of the matrix that we will have as a result. Think. Yes, it's 3 by 2. You always just remove these two, and so it's 3 by 2. So how we do that, how we calculate that. We saw how to do it with a vector, but we didn't see how to do it with a matrix. So first, you multiply the first matrix with the first column, which is a vector. That's a vector, right? If you like see just 2, 2, 1. So you take the first column as a vector. You do the multiplication. We already learned that in the previous slide. And the result is like that. So you just take 0 by 2 and 3 by 2, that's 6, and 1 by 1, that's 1. 6 plus 1 equals 7, and so on and so on. Then you take the second column of the second matrix here, this one, 1, 0, 4, like that, and you multiply it with the first matrix. So yeah, and you do this multiplication as we learned before in simple vector multiplication. 0 by 1, 0, 3 by 0, that's 0 also, 1 by 4, and that's 4. So the first element is 4, the second 5, and with the third row 17. And that's how we did the multiplication. But we have the result for this multiplication. We have the result for this multiplication. But what's the result for this multiplication? Matrix to matrix multiplication. Simply just take the first result and the second result, concatenate them together in one matrix, and you have your result. That's all. I hope you understood this. If you see it for the first time, of course, it's a little bit complicated. But yeah, I hope you understood this. And as we said before, the, the result matrix takes the first dimension of the first matrix and the second dimension of the second matrix as dimensions. So yeah, thank you very much. I hope you understood this. And actually, I have good news for you. You need definitely you need to understand all of this, but usually in our course you won't need to calculate everything by yourself. Actually, it's all done inside the programming languages, so you don't need to worry about that so much. Thank you very much, and see you in the third video on linear algebra in our course on machine learning. See ya next time.